Hello friends, see here in Maths2 Similarity we'll take the next part, that is Theorem, which is very important one. That is nothing but areas of similar triangles. What is this? See the first statement, that is very important. The ratio of areas of two triangles, is equal to square of their corresponding sides. In first four properties of this topic also there is the ratio of areas, but in that four properties there are different bases, different heights, same bases, same heights, both are same, like that properties are already we learned. But now in this property, the two triangles are similar. Now we are going to take the ratio of their areas of two similar triangles is equal to the ratio of squares of their corresponding sides. Okay? So we will take first, we will draw the figure from the given information, then we will write given to prove some construction, and then step by step we will prove the proof of this particular theorem. Okay friends, see first, I will draw the figure. See first, this is very important one. This is the first triangle, we will say as ABC. Now we are going to take one more triangle. Both these are similar. They are given to us, we will take as PQR. Okay friends, what is given part here? Both these triangles are similar. Okay? These two triangles are similar. What we have to prove here? We have to prove the ratio of areas of these two triangles. Means what? Area of triangle ABC upon area of triangle PQR is equal to what? The corresponding side AB, PQ. These two are corresponding. Or you may take BC, QR. Or you may take AC, PR. Okay? So we'll take here AB square upon PQ square, or BC square upon QR square, or AC square upon PR square. Okay? Like this is the part which we have to prove. Okay? Now, we are going to make some construction. Okay? We need what? Area of the two triangles. In first four properties, what we learn? If they have same bases, same heights, or both are same, or both are different. If you observe here, these two are only similar. That means base is different. Similarly, their height is also different. Means we have to use the property number 1, which is the ratio of areas of two triangles with different bases and different heights. Okay friends? So we'll take, for that what we need here? Height. That height we are going to draw first. So this is our construction. We'll draw AD perpendicular to BC and here PS perpendicular to QR. That one we'll write in construction part. Okay? What is that? Draw AD perpendicular to BC, where D is in between B and C. Okay? And that side PS perpendicular to QR. Here also that S is in between Q and R. Okay? That is Q dash S dash R. This is our construction. Okay friends? Now, look here. I'll first explain how we are going to prove this one. And then we'll write one by one steps. Okay, see first. We need this part. Means what? We already know these two triangles having different bases and different heights. Means as our property number 1 what tells us? ABC upon area of triangle PQR is equal to their, what is that? Products of their bases and heights. Means here what? BC and height is what? AD. Okay, just try to understand. and this side QR. This is what? PS. Okay, what we need? We cannot prove all the three. We can prove any one, and similarly we can prove remaining two. See first, in this particular part, what is there? BC and QR. That means this one is equal to BC square upon QR square. If we prove, then remaining two we can prove similarly. Okay, that means BC upon QR is we have. So I'll make separate here. See, BC upon QR into AD upon PS. Okay, if we replace this by again BC and upon QR, then that will be our proof. Yes, BC upon QR into BC upon QR means BC square upon QR square. That will be the proof. But the next part is what? How we can prove these two are same. That is very, very important. Okay, if you prove these two are same, then just replace this by BC upon QR. That will be the proof. Understand? So now look here, where it is AD and PS, here it is AD and this is PS, and BC, QR, these two are. If you observe here, AD and BC, by these two we cannot make any kind of triangle here. Okay, that means it is like a transitivity. So how we can use this transitivity property here? See here, AD which is not in the triangle in which BC is there. That is, AD is not a side. Okay, so I will take here AD which is side of this side triangle. Is it correct? In which AB is there. Okay, here PS is a side which is in a triangle of this side triangle in which PQ is there. Okay, now one more triangle ABC in which AB is there and BC is there. That means first of all we have to take these side triangles we are going to make, they are similar. Let's see how we can do that is afterwards. First, this is our step number 1, which is this side. If we prove these two sides are means ADB and PSQ, if we prove they are similar, then their corresponding sides are in proportion. Okay. Now already what we know here, these bigger two triangles are similar. That means their sides are also in proportion. Means what? AB upon PQ, BC upon QR, and AC upon PI. Okay. And after proving this ADB and PSQ are similar, then their sides are also in proportion. In these two, this AB upon PQ lies in the given part as well as in proved part. So by these two, we can say that AB upon PQ is in both sides. Therefore, remaining all means in all there are 6, but AB upon PQ is 2 times. That means 5 ratios are same. Okay. So in that 5 ratios, what is there? AD upon PS also be there. With the same time, BS upon QR also be there. In this way, we proved these two are same. And once we proved these two are same, now here in this step, replace this AD upon PS by BC upon QR. Then the next part will be finished. That is BC square upon QR square. Now, similarly, we can prove this AB square upon PQ square or AC square upon PI square. How? As like AD is perpendicular to BC. Similarly, we can draw from C to AB perpendicular. Then here we can prove AB square upon PQ square. Or if we draw perpendicular from B to AC and here from Q to PR, then we can prove this AC square upon PR square. But that part we no need to prove here. Just prove one part, this is BC square upon QR square, and remaining part we can prove similarly. Understand? Now we'll take one by one steps. They are very, very important. See here, we'll write proof one by one step. Okay friends, see here, proof. We'll write step number 1. What is that? First I'll write the given part. What is the given part? Both the triangles are similar. So triangle ABC similar to triangle PQR, which is given. I'll write the reason also. Okay. Now, if the two triangles are similar, what you can write? Their sides are in proportion and angles are also congruent. So which angle we can take congruent? Actually, A to P, B to Q, and C to R. All these three angles are congruent. Okay. but we take just what we need. We take these two triangles are congruent. No, we have to show similar. For that reason, I will take B and Q only. We take. Okay. See first. AB upon PQ, BC upon QR. These are corresponding sides. AC upon PR. This is corresponding sides of similar triangles. And here only we can take all angles, but no need to write all angles. Only we need which angle we need know, that much only we write. So we write here angle B congruent to angle Q. This is corresponding angles of similar triangles. Okay. Now after writing these two, here see, we'll write their ratio, means using first property. What is that property number 1? Area of triangle ABC upon area of triangle PQR. In these two triangles, base and heights both are different. Means the ratio is depend upon their products of base and height. BC into AD and this side QR into PS. Is it correct? BC into AD, QR into PS. This is what? Triangles having different bases and heights. Okay? Now, I will just separate here. Area of triangle ABC upon area of triangle PQR. Here I will just make the separate here. BC upon QR into AD upon PS. Okay? This is just from third step. Now, what is next part? We are going to prove this side too. Just try to understand. Instead of proving these two sides triangles are similar, you may prove these two also. Yes, anything you can prove. So right now ADB in triangle ADB and triangle PSQ. This side. We know what we can do here now. See here, this is angle, this is the angle which is right angle. Okay, now this B angle and Q angle already we know in second step. That is one. If you want to prove these side triangles, then instead of B and Q, we can write C and R. Okay, friends? Now look here. Angle ADB. Look here. Congruent to PSQ. This is each 90. From where it comes? It is from construction. Okay? Now, one more angle we need here. That is angle B to angle Q. Angle B congruent to angle Q. This is from second step. Therefore, the two triangles become similar, which is ADB similar to, you can write PS2, but whenever you write this similarity, at that time, try to verify whether the vertices are in corresponding or not. How we can write? See here, this is the vertex of angle D to S, here it is B, that means we have to write S in the middle part. Similarly, B to Q, okay, where it is B? Last, so we write here last Q. And remaining vertex, just where this place is there only we will write it as a PR. Understand? This is by AA test. Look here, once the two triangles are similar, we can write their corresponding sides are in proportion. See, AD upon PS, is it? DB upon SQ, and the last AB upon PQ. This again corresponding sides of similar triangles. Okay. Now look here, this is very important part. In the step number 2 and step number 8, what are you observing here? Here, this AB upon PQ is in both the steps. Because of that one, we can write all the 6, means 5 ratios are same. Okay? See here, 9th step, what you can write? All these 3 with the same time, these 2. Means what? AB upon PQ, BC upon QR, AC upon PR. Now you write AD upon PS, and this side dB upon S cube. Okay, this step will from 2 and 8. From 2 and 8. Okay, now that means up to here you understand. See first, in our discussion what we told you? See here, this is the BC upon QR and here it is AD upon PS. Both these becomes now same. Yes? Now only the part is what? Here the AD upon PS is there. We want to replace this AD upon PS by that BC upon QR. That is the proof. See. Area triangle ABC upon area triangle PQR is equal to BC upon QR into, we are going to replace this area upon PS by again BC upon QR. This is from which step? From 4th and 9th we can write here. From 4th and 9th step. What is the next step? See here. Area triangle ABC upon area triangle PQR is equal to what? BC square upon QR square. This is from step number 10. Yes? Now what is the remaining part? Similarly we can prove, similarly as like BC and QR, we can prove that AB PQ or AC PR. That one we can write here. Similarly, area triangle ABC upon area triangle PQR is equal to AB square by PQ square, or you may write here or AC square upon PR square. This is similarly, that means no need to write the result. Okay, now the last step, which is our proof, that is area triangle ABC upon area triangle PQR is equal to AB square upon PQ square, BC square upon QR square, or you may take here AC square upon PR square. Like this we can prove, and this is from 11th and 12th step. Understand? Like this we can prove this is the very important theorem. Friends, if you observe here, if you understand, then I will tell you that one very important part depend upon this one. Okay, see here. As like BC upon QR into AD upon PS is there, and we replace here AD upon PS by BC upon QR. Why? Because both are same. We need BC upon QR, that is why replace AD upon PS by BC upon QR. But we can remove this BC upon QR by AD upon PS, then what we can get here? AD upon PS means AD square upon PS square also. What is AD and PS? Both these are, you may write here, perpendicular, or you may say here, altitudes. Means the same theorem we can write in the form of altitudes also. Means what? Look here, I will write here, area of triangle 1 upon area of triangle 2, which these two are similar. So here this is S1 upon S2 square. This is corresponding sides. So instead of sides, you may write here altitudes also or heights also. That is height 1 square upon height 2. Height H1 means AD, PS is H2. AD and PS, similarly just I told you, instead of replacing AD upon PS, we may replace BC upon QR also. Okay? But sometimes in the same manner, we can prove here M1 square upon M2 square. There are medians also. So this property we can apply in some examples also. That is why this one is very important. Understand friends? Just watch carefully, try to make practice carefully, then you can understand. Okay? Okay. Now, depend upon this theorem, what we proved now. So, practice set 1.4 is there. So, in that whole practice set is depend upon just previously proved theorem. Okay? See here, first example. The ratio of corresponding sides of similar triangles is 3:5. that is given to us. Okay, now we have to find the ratio of the two triangles areas. See here. So here we suppose the two triangles as ABC and PQR. Okay, we suppose here. Let triangle ABC similar to triangle PQR. This is our supposition. Similarly, what they are given to us? AB and PQ. We suppose that corresponding sides. Means what? And AB is to PQ, that is 3 upon 5, 3 is to 5. So just by that property, by which property? By areas of similar triangles, we can write now triangle ABC, that is area of triangle ABC upon area of triangle PQR is equal to, just write corresponding sides. You can write any sides, but we already suppose AB and PQ. Okay, remember, don't forget to write this square. So in this particular property, that is square. In first four properties, there is no square. In that one, height is same, base is same, like that. Here, no height, base same, like that. Okay, so now I'll put the values. What do we do? But don't put here AB means 3, PQ means 5. We cannot put. That is a ratio. We cannot make separate. So for that reason, I'll write this square combined. Like this one. Now we can write AB upon PQ means 3 upon 5. That is a square. So here 9 upon 25. So this is 9 is to 25, which is nothing but area of triangle ABC is to area of triangle PQR. But everything is our supposition. So write in words. So what is that words? The ratio of areas of similar triangles is 9 is to 25. Always the final answer should be in words. Okay? Understand? Now take second. See here, second and third examples in which that is activity based examples, in which the information is like that given to us and there are some fill, that is blank boxes are there and we are going to fill them using our property. Okay, see first here. That is very important. Look here first. In the second example, what they given to us? Triangle ABC and triangle PQR, both these are similar. AB and PQ, the ratio is given to us, that is 2 is to 3. Okay, now the ratio of these two areas of these two similar triangles. What you can write? Corresponding side square. So here AB square. So tell me, if here AB square is there, then what will come here now? That is nothing but here PQ is there. Square is there, so straightway write here PQ square. You can write by areas of similar triangles. Okay? Now here, and AB upon PQ, here it is 2 upon 3. Remember, again I am telling, in between these two steps, actually the step is there. That is nothing but AB upon PQ square. So here you can write 2 upon 3 square and then that will be the 2 square upon 3 square. Understand? So here these steps no need to write, but sometimes you are going to do in the rough section. Okay? Here after taking 2 square and 3 square, here it is 4 and this is 9. Like this we have to fill the boxes. Okay? But totally depend upon that theorem. Now here also in the third example. These two triangles are similar again. And now the areas of the two similar triangles is given to us. One is 80 and other one is 125. Okay. Now we have to put the values here in the boxes. But we cannot put directly. We have to simplify something. That one we can simplify in rough sections. Okay. See first. The ratio is given to us 80 upon 125. But as you know, these two triangles are similar. That means by areas of similar triangles. What you can write? The area of triangle ABC upon area of triangle PQR is equal to which side we need here? AB and PQ. means you can write here AB square upon PQ square. So by these two steps we can equate these two are same, means AB square upon PQ square, which is 80 upon 125. Look here, very important part is what? Wherever square is there, at that time we are going to make square root to both sides. Look here, if we make square root here and here also, but these two are not perfect square root. Whenever like this one, at that time must be they are divisible by some numbers. If you observe here, this is 16 fives are. Okay, see here, 16 fives are, and this one is 25 fives are. Understand? Now getting these 5 getting cancelled, there is common multiple getting cancelled here. Now taking square root here, this is nothing but AB upon PQ, and here it is 4 upon 5. Now these values we are going to put up here. That means whenever in activity based examples, don't try to put the values directly. In the middle steps you have to solve somewhere, or you may solve in the same example also. Okay? We'll take the fourth sum. See here, triangle element similar to triangle PQR is given to us. In here, observe here, 9 into area of triangle PQR is equal to 16 into area of triangle element is given to us. And at the same time, QR is given. From that, we are going to find MN. Observe here, whenever the information is like this, we can write the ratios. I'll write first that part. See here, 9 into area of triangle PQR is equal to 16 into area of triangle LMN. Okay? So, here element is the first part. So, that element should be, we'll write here in numerator. You can write in denominator also, but I'll write in that form. So, see here, keep this area of triangle element here only. Okay? Now this side, area of triangle PQR goes to that side, which will go in denominator. Here, this already 9 is there. That 16 comes to this side, that will goes in denominator. This is the given part, as like in the given example, in the previous sum. Okay? Now, as the two triangles are similar, triangle LMN similar to triangle PQR, therefore, by areas of similar triangles, by that property, we will write here now area triangle LMN upon area triangle PQR is equal to, we have to take one side. We can take any side, but then given to us QR is given and MN is we have to find. So these two only, MN and QR, they are corresponding sides. So LMN is there. So MN square upon QR square. We will put the values here. So LMN upon PQR, here is nothing but 9 upon 16. Okay. This side, MN square, we have to find. QR is given. So MN square and QR 30 square. Okay, don't forget that one. Now just observing 9, 16, this side square. So taking square root to both sides. Right here. Taking square root to both sides. What will come here now? 9, that is 3. 16, which is 4. This side, just write MN, and here it is 30. Okay? Now just go with cross multiplication, or take that 30 to this side. So 3 into 30 upon 4, and we can find MN. See, it is divisible by 2s, 2 2s, 2 15s, or 2 1s, 1 remains, 2 5s. So here it is, MN means 15 3s, 45 upon 2. So MN is nothing but 22.5, which is half of 45. Understand? We'll take now fifth. See here, what they are given to us in fifth sum? There are two similar triangles. Okay? And they are given to us areas of given two similar triangles. One is 225 square meters and other one is 81 square meters. Okay. Similarly, what are given to us? One more thing. The corresponding side of smaller triangle is 12 meter. Okay. So using this information, we are going to find corresponding side of bigger triangle. Okay. Now look here. Alright. Again, we'll take the names as you can. ABC, PQR. Okay. We'll take here. Let the bigger triangle be ABC and the smaller triangle be PQR, and both are similar, they were given to us. Okay, now area of bigger triangle ABC, that is given to us 225 square meters, and area of smaller triangle which is PQR, that is 81 square meters. Okay, now see here which triangle is smaller. Triangle PQR, and then given to us corresponding side of smaller triangle, means we can take here PQ, which is corresponding, and we are going to find AB, which is the corresponding side of bigger triangle. So we'll write here side of, you may write here side of smaller triangle, that is we can write here PQ, which is 12 meter given to us. Okay. Now we are going to find A. See first of all, what is given to us? These two triangles are similar. Okay, by areas of similar triangles, means area of triangle ABC upon area of triangle PQR is equal to, we'll take just corresponding side, which is here AB square upon PQ square. We'll put again as we see in the last example, very similar example. Here AB, which we have to find, and PQ we have given, that is 12. See here, very simple, taking square root to both sides. Taking square root to both sides. What will get tell me? Here both these are what? Square roots. We can find. 225 means it is a perfect square of 15, and here it is 9. So write here 15 upon 9. This side AB upon 12. Okay. Now the next part, we'll take the 12 to this side. So 15 into 12 upon 9, which is AB. So divisible. 3 3s are 3 5s are. 3 1s are 3 4s are. That means AB is equal to 5 4s are 20 meters. What is AB? Which is bigger side, corresponding side of bigger triangle. Okay, therefore corresponding side of bigger triangle, that is AB, which is 20 meter. Or look here, sometimes they are given to us square meters, maybe sometimes they are given to us square centimeter. If you have meter, then everything write in meters. If they are given to us square centimeter, we write everywhere in centimeter. Understand? Okay, now we take sixth sum. What is sixth sum? There are ABC and DEF. Here these are the two equilateral triangles. Okay. Now they are given to us the ratio of areas of these two triangles, that is area of triangle ABC is to area of triangle DEF is equal to 1:2 they are given to us. Similarly, AB is equal to 4 is given. So from that we are going to find DE. Okay. See first, they are similar. Just try to understand. One more thing I am telling you, whenever the two similar triangles are there, they are always similar. Whenever the two triangles are equilateral triangles are there, then they are always similar. Why they are similar? See, if they are equilateral triangles, see first, here it is, one triangle is equilateral triangle, one more triangle is here equilateral triangle. Just observe it. Okay. They are equivalent triangles means all the sides are same. Okay. Now they have all angles are 60 because of equilateral triangle. See first, by AA test we can prove these two triangles are similar. But no need to prove. Yes, whenever the two triangles are similar, they are always similar. Equivalent triangles are there, then they are similar. Okay, see first. Triangle ABC and triangle DEF are equilateral triangles. Therefore, straightway we can write ABC and DEF are similar. Okay? Now, once these two are similar, what they are given to us, the ratio is 1:2 they are given to us. Okay? We'll write by areas of similar triangles. We can write area of triangle ABC upon area of triangle DEF. Yes. So now we can write one side which is corresponding. What which you can write? AB and DE. So write AB square upon DE square. This ratio is given to us in the given part, which is 1/2. This side AB, they are given to us 4. And D we have to find. See here. Here also we are going to take square root to both sides. Why? D square is there. We need just D. That is why taking square root to both sides. Taking square root to both sides. What will come here? 1 square root is 1 only. 2 square root 2 here. This is 4 square means we can write just 4 and here it is D. Understand? Go with cross multiplication. That will be the D. D ones are D and this side 4 root 2. Understand friends? Just by mistake I told in the starting of this example these two are similar. No, they are equilateral triangles. Okay? Because of their equilateral triangles, they are always similar. So see here, because of their equilateral triangles, therefore they are similar. No need to prove, we can write directly. They are similar, they become similar now. Using this property, we can apply the property and try to put the information what they are given to us. Simplify, we find what we need. So DE is equal to 4 root 2. Okay?
Hello friends, this is the last sum from practice set. This is actually activity sum, 7th one. See here, in this figure, they were given to us, this is DEF, in which PQ is there, okay, where PQ is parallel to DE, okay. Now, area of triangle PQF, which is here, PQF. This area of this areas of this triangle is given, which is 20 units. Actually, here it is 20 square units. Okay, and PF, which is twice of DP. This is PF, which is twice of DP. From this, we can find DF also. Okay, then find area of quadrilateral DPQE. Where it is? DPQE. We have to find the area of this quadrilateral. Okay, so this is, we have to complete the activity. Here see, area of triangle PQF, which is 20 square units. Here should be square units. Okay, this PF is equal to twice of DP, as like they're given to us. Let us assume DP, this DP be X. Okay, therefore what will come here? PF, which is nothing but 2X. Okay, because they're given to us DP, if you take X, then PF will be twice of X, like this. Okay, now from this we have to find DF. This is the full DF, means DP plus PF. Here it is. That means what will get here now? DP plus PF. So friends, we have to write here, okay, this is PF. Okay, afterwards, now DP plus PF, this is DP, this is PF. So already we know DP means what? We suppose here X. Okay, so we'll write here X. Afterwards, what about PF? This is 2X. So we'll write here this is 2x. Okay, in all we get here 3x. Now after that, in triangle FDE, and FPQ, this is FDE bigger one and this is the smaller one. Okay, in these two triangles. See, first they're given to us, these two are parallel to each other. Therefore, straightway we can write this angle is nothing but this angle because of corresponding angle. Similarly, this angle is congruent to this angle. Again, this is by corresponding because of these two are parallel to each other. Okay, and similarly this angle is what? Common angle. Okay, if we'll take, or by AA test also it is no need to take. See first, FDE, where it is? FDE means this angle which is congruent to this one. Why? Because of corresponding angle. That means what we have to take here? Which angle we have to write here now? See, F P Q. Okay, this is the angle. Afterwards, FED, where it is? FED, which is congruent to FQP, that means this angle. Again we have to write here FQP. Okay, okay, like this. Therefore, here these are the two triangles which are similar. Understand? Now, when the two triangles are similar, then by using our last property, what is that? Area, the ratio of areas of two triangles which are similar, which is equal to ratio of squares of their corresponding side. Means we have to write here corresponding sides. Which side we have to take? The discussion is about DP, PF, okay, or DF. That side only we have to take. So here it is, the corresponding side will take DF to PF. Okay, so we'll write here FDE means FDE bigger one, so we'll write here DF. Okay, but not only DF, which is square. Similarly, here it is what? PF. Again here also square. Okay, and try to understand. Similarly, now what about DF? DF, which we'll find just now, which is nothing but 3x. So because of square, so we'll write here 3x square. Now similarly PF, already we know 2x, put up here 2x square. So here 4. So here x and x both getting cancelled. So here 3 square upon 4, 2 square, which is 4. So now area of these two, just go with cross, or instead of take this PFQ to this side. So here it is. Now we can put the value of area of triangle FPQ. How much? FPQ 20. We can write here 20. Okay. Now the next part is only simplification. See here, 4 ones are 4, 4 5s are 20. Okay, therefore 9 5s are 45. Like this. Similarly, now the next part is what? Area of DPQ. DPQE means this particular quadrilateral. How to get this one? Which is this triangle minus this triangle, which will get this quadrilateral. So FDE means what? Bigger one, which will just find 45. That one will write here first 45. Okay, and then this smaller one, which is already they were given to us, which is 20. So we'll write first 20 here, and then the next part, which is subtraction, which is 25. Okay, so don't forget to write square units. This is very, very, very important one. By mistake in the given textbook, by mistake here it is the given information, square is missed. So don't forget to write here this unit. This is area of quadrilateral DPQE, which is 25 square units. Okay friends.